let's be real, we've all been there. Your AWS Lambda function is chugging along just fine, and then, bam, it fails. At the worst possible time, of course. Well, you are not alone. Today, we're going to build a troubleshooter's field guide to cut through those cryptic error messages and get your functions back up and running fast.
This right here, this is the question. It's the universal cry for help from every single developer who's ever used Lambda. You know the feeling. It's late, a deadline is breathing down your neck, and you're just staring at the screen. It's frustrating, but don't worry. By the end of this, you're going to have a clear mental map to find the answer every single time.
So, here's how we're going to break it down. We're going to follow the life of a function. We'll start with configuration conundrums, then dive into deployment dilemmas, untangle some runtime riddles, and finish up with connectivity conundrums. This is your complete map of all the places things can go wrong.
First up, configuration conundrums. You might think the bugs only live inside your code, right? Well, with Lambda, some of the most head-scratching issues happen before a single line of your handler even gets a chance to run. It all starts with how you set things up.
Okay, here's a pro tip that feels totally counterintuitive at first. Let's say your function is slow. It doesn't matter if it's slow because it's doing heavy math or because it's gobbling up memory. The solution is the same. Give it more memory. Why? Because Lambda allocates CPU power in direct proportion to how much memory you give it. So more memory literally equals more processing power.
Now for a real silent killer, the memory leak. In the serverless world, this is a tricky one. It happens when you declare something in the global scope, outside your main handler. Each time your function gets invoked while it's still warm, meaning the container is being reused, that object can grow and grow and grow, slowly suffocating your function by eating up all its memory.
And this is what it looks like in the wild. This is the first sign of trouble. Everything's running smoothly, and then you see these weird dips. The number of successful invocations just starts to drop off. That's your function struggling for air as the memory gets tighter and tighter.
As that memory pressure builds, the underlying operating system gets desperate. It starts using the disk as extra memory, which is incredibly slow. And you can see it right here on the graph. The function's duration, which was nice and low, suddenly spikes. I mean, it just goes through the roof.
And here we are, the final stage. The function is now so slow that it starts hitting its timeout limits, or the whole environment just crashes. That's when you see this sudden wall of red. The errors just appear out of nowhere. Then Lambda finally steps in, kills the sick environment, and spins up a fresh one. And the whole cycle starts over again.
All right, next up, deployment dilemmas. This is that moment where you've written your code, you've zipped it up, you go to upload it, and Lambda is just like, nope, not today. These are the errors that stop you before you even get out of the gate.
Oh, this one, a true classic. If you've ever seen this permission-denied error, you know how maddening it is. You're thinking, I know the file's in there. Why can't you open it? It comes down to a really simple but crucial detail.
The culprit is almost always Linux file permissions. Remember, your function runs in a Linux environment, and that environment needs permission to actually read your files. So before you zip up your code, just run a quick chmod 644 on your files and a chmod 755 on any directories or executables. Problem solved.
Okay, here's another deployment roadblock. You try to upload your package and you get smacked with a request entity too large exception. This time, it's not about what your function can do, it's about its size.
Yep, there's a hard limit. You can only upload a 50 megabyte zip file directly to Lambda. Anything bigger, and it'll fail. But the workaround is super easy. Just upload your big zip file to an S3 bucket first, and then simply tell Lambda to grab the code from there. It's the standard way to handle larger deployments. All right, let's move into our third category, runtime riddles. So you got past configuration, you deployed successfully, your code is actually running, but now, in the middle of processing an event, things are just not working.
So has this ever happened to you? You write your code, you run it on your super fast developer machine, and it's instant. Then you deploy it to Lambda, and it just crawls. What is going on? Well, it's a huge clue that you're hitting a resource limit up in the cloud.
And look at that, we've come full circle, right back to our first tip. 9 times out of 10, the problem is that your function is being starved of either memory or CPU. And since we know they're linked in Lambda, the solution is, you guessed it, increase the memory configuration. That'll give your code the breathing room it needs to run just as fast as it does on your laptop.
You know, there is nothing worse than flying blind. Your function is failing, but you go to check the logs in CloudWatch and,
There's nothing there. It's a ghost town. This is almost always an IAM permissions issue. Your function's execution role needs the AWS Lambda basic execution role policy to write logs, and if you're using X-Ray, it needs the AWS X-Ray daemon write access policy for traces.
Okay, now for a really dangerous one, the infinite loop. Picture this. You have a function that gets triggered when a file is uploaded to an S3 bucket. But then, inside your function's code, you write a new file back to that exact same bucket, which, of course, triggers the function all over again, and again, and again. This can run up a massive bill in just a few minutes. So, how do you stop this runaway train? You've got a few solid options. The simplest is to just have your function write its output to a totally different place, like a separate processed files S3 bucket. If you have to write to the same bucket, make sure your output files have a different prefix or suffix so they don't match the trigger. Or you can get even smarter and add a metadata tag to the file that your function can check for so it knows not to process the same data twice.
All right, let's dive into our final section. And honestly, this one can be a real headache. Connectivity conundrums. This is all about what happens when your Lambda function needs to talk to other resources that are tucked away inside a virtual private cloud, or VPC.
If you've ever put your function inside a VPC, and then, all of a sudden, you start seeing these nasty timeout errors whenever you try to call an external API, yep, you've just fallen into a very, very common trap. Your function has lost its connection to the internet.
Here's the absolute key concept to understand. The moment you attach your Lambda function to a VPC, you fundamentally change its networking. It no longer has a default path out to the public internet. All of its traffic is now forced to go through your private VPC, which, by design, is locked down and isolated.
So how do we fix it? Well, there's a standard architectural playbook for this. First, you create what's called a NAT gateway. Think of it as a secure bridge to the internet. Second, you put that gateway in a public subnet inside your VPC. And finally, you just update the route table for your function's private subnet to send all internet traffic to that NAT gateway. And just like that, you're back online.
We've gone all the way from sneaky memory leaks to the deep end of VPC networking. But the goal here isn't just to get better at putting out fires. It's to stop the fires from starting in the first place. So I'll leave you with this question. Which one of these failure patterns are you going to proactively build a check for in your next CI/CD pipeline? Thanks for tuning in.